Hello बच्चों, let us read the question. When a particle is restricted to move along x-axis between x is equal to 0 and x is equal to a, where a is of nanometer dimension, its energy can take only certain specific values. The allowed energies of the particle moving in such a restricted region correspond to the formation of standing waves with nodes at its end x is equal to 0 and x is equal to a. The wavelength of this standing wave is related to the linear momentum p of the particle according to the de Broglie relation. The energy of the particle of mass m is related to its linear momentum as E is equal to p squared by 2m. Thus, the energy of the particle can be denoted by a quantum number n taking values 1, 2, 3, etc. N is equal to 1 called ground state, corresponding to the number of loops in the standing wave. Use the model described above to answer the following three questions for a particle moving in the line x is equal to 0 to x is equal to a. Take h is equal to 6.6 into 10 to the power of minus 34 joules second and E is equal to 1.6 into 10 to the power of minus 19 coulomb. The allowed energy for the particle for a particular value of n is proportional to option a to the power minus 2, option B, a to the power minus 3 by 2, option C, a to the power minus 1, option D, a squared. तो इस क्वेश्चन का की कॉन्सेप्ट है रिलेशन बिटवीन मोमेंटम एंड wavelength of a particle. तो ये रिलेशन को de Broglie wavelength से हम लिखते हैं. So the de Broglie wavelength of a particle lambda is given as h by p, जहाँ पे p है momentum of the particle. तो इस क्वेश्चन को सॉल्व करने के लिए पहले हम ये देखेंगे कि what is the standing wave equation for n loops. So we know that standing wave equation जहाँ पे the length for length and number of loops. So that is essentially given by L is equal to n lambda by 2, जहाँ पे lambda है wavelength of the standing wave. So using de Broglie equation from the de Broglie wavelength, हम ये लिख सकते हैं कि लैम्डा इज इक्वल टू h बाई p और क्वेश्चन में ये दिए है कि दी एनर्जी इज गिवन एज p स्क्वायर्ड बाई 2m. सो देयरफॉर वी कैन राइट p इज इक्वल टू स्क्वायर रूट ऑफ 2me. तो इस p के इक्वेशन को हम लैम्डा में सब्स्टिट्यूट करेंगे एज स्क्वायर रूट ऑफ 2me. So now substituting lambda in the L equation. So therefore L is equal to n by 2 into h by square root of 2me. तो हम एनर्जी के टर्म्स में लिखेंगे. So E will then be n squared h squared by 8m L squared. So we know that x is equal to 0 to x is equal to a is the length of the standing wave. So therefore हम energy लिखेंगे. So for the length will now be a minus 0, which is equal to a. So energy will be n squared h squared divided by 8m a squared. So for a given value of n, h, m or n constants है. So therefore E will be proportional to a to the power of minus 2. तो अभी क्वेश्चन पे जाके हम करेक्ट ऑप्शन मार्क करेंगे. The allowed energy for the particle for a particular value of n is proportional to, तो हमें आंसर मिला a to the power minus 2. So the correct option is option A. Hope you have understood it well. Best of luck.